Okay, let's start solving a couple of problems real time, like I told in the last video. And these are examination problems. So, like, let's solve it together. That's why I have written like solve it with me instead of pre-writing it. So let's figure out. So I've taken some of the examples just for the problems that are related to defactorizations, and then in the next video I'll talk about all the factorization problems. So typically, like I said in the previous video, there are two questions come in each question paper, roughly 4 marks each, and normally one of them is for defactorization. And these are the problems. And if you see here, for the last 2 years of question papers, summer and winter, the problems are pretty much repeated. The first problem on the cost side is repeated thrice, pretty much without any variations, in summer 2018, winter 2018, and some winter 2019. And on the other exams, I think I'm missing the year here. I think this should be summer 2019. I'll add it up. So if you see this, there's just one variation of sign, and it's going to be the same. So I'll solve live for one on the cost side because it's repetitive, and the sign one I'll pre-solve it and put it there in the other video and just walk you through. So let's break this down. So if you see here, like I told in the previous video, you'll see that there are too many of cos angles. And how do I figure out that I'm going to apply the type 6 defactorization formula? So one of the things that you'll notice is all the angles are like pretty much everywhere. It's 20, 40, 60, 80. And you'll see that it's multiplication. It's product of cos signs, and it will easily to be able to relate that for the product of cos sign, you can easily apply the formula, which is, I'm going to write it on the side here, where it says 2 cos A into cos B is equal to cos of A plus B plus cos of A minus B, right? So you know this formula, and so if you see here the patterns, it matches here. So let's write this problem down here and then solve it easier for you. So the problem states, okay, so prove that something on the left hand side is equal to something on the right hand side. So your left hand side is cos of 20 into cos of 40 into cos of 60 into cos of 80. Okay, and the right hand side is a value which is 1 by 16. So like as always in the trigonometry, like I told you, the answer is already given, so you have to just prove it. So you have to just make sure that the left hand side eventually, after you substitute, comes to 1 by 16, and if it's not coming, then you're doing something wrong, and which is a good thing because you know the answer. So if you see here the pattern over here, if you see here, this matches kind of thing, this matches here on this one, right? If you see here, this kind of matches here. So it's cos and cos and cos and cos over here, and so we have to apply this formula. And the beauty is, if you see, there are 4 cos terms, and out of this, one of the cos terms, you know the value. So cos of 60, you already know that the value is equal to half, so you don't have to worry about that. That leaves you with these 3 terms, cos of 20, cos of 40, and cos of 80, right? And you have to solve that. And now there are 2 cos functions here, cos A and cos B. So, and there are 3 functions here, 20, 40, and 80. So which one should you pick up as a A and for a B? The beauty is it does not really matter. You can pick up any 2 angles between these 3, cos 20, cos 40, and cos 80. You can pick up any 2 the way you want, and you can solve for that. And since you can only have 2 cos functions, it's very obvious that you have to apply this formula twice. You have to pick up 2 functions first, apply this formula, and then based on the formula, you again take the third function and again reapply this formula. So you have to apply this formula twice. That's kind of the trick here. And if you take any of these 2 angles, right, like I told you in the last video, you take any of these 2 angles, if you add it up, it will give you at least one angle. So over here, if you see, there is one angle which is a summation, and there is one function which is more of a difference, right? So when you do a summation or a difference on any of these 2 angles that you pick up for cos and cos B, you'll always find that one angle will kind of translate into a standard angle or a reference angle for which the value could be easily computed. and the other angle will not be that easy. And again, when you substitute the second time, it will give a easier value. For example, if you take 40, the first two functions cos 20 and cos 40, and if you add that up, a plus b, so you'll get 20 plus 40 is equal to 60, and you know the value of cos 60 is very easy to compute. And the a minus b is cos 40 minus 20 or 20 minus 40, however you take that, the net is 20 degrees, which is difficult. But when you again substitute that with this angle in the second iteration, you will get that. Alternatively, if you pick up 80 and 40, it's 120, and you know that can be solved. So like I said, either the addition of the two angles or the subtraction of two angles, one of those two angles will be always an easy value, and then you have to fight for the other value. That's how these problems are structured. So the way I do it, the first and foremost thing that you do it is always arrange the values in the descending order. Take the angles which are greater first. In this case, I'm going to take this cos 60 over here. I'm going to write it down because it's already there, so I'm going to write it down separately, 1 by 2, and then I'm going to rearrange it in the descending order. So it's cos of 80 into cos of 40 into cos of 20. Okay, that's how I'm going to write it. And then what I'm going to do is I'm going to take any two angles. So in this case, I'm going to take the first two angles. So this is going to be your a cos 80, and then I'm going to take this for cos 40 as the b function over here, cos a and cos b, and apply that. But if you see over here, you need 2 to apply it here, so I'm going to bring the 2 inside first. And that the very easy way to do that is you take this half as it is and multiply this function and divide this function by 2, so that you get this 2, and then you say cos of 80 into cos of 40. Okay, and then you keep this cos of 20 separate for now, so that this equation this looks like your a and this looks like your b, right? And I'm going to solve that separately here. Okay, and if you take this also needs to be part of this equation. So if I take this, it matches like a 2 cos a cos b is equal to 2 of cos of 80 and cos of 40, right? And this formula maps to cos of a plus b plus cos of a minus b, right? So if I apply the formula over here, it gives me cos of a plus b is cos of 120 plus cos of 80 minus 40 is 40, cos of 40. So this is how it's easily substitutes. And you know that this particular piece here, cos of 120, right? Cos of 120 is nothing but you can calculate it multiple ways. You know that it's a obtuse angle, and the standard angle or reference angle could be 60 degrees. You can apply that way, or the other way to do that is you can apply the allied angle, in which case cos of 120 will become cos of 90, and you can say 90 plus 30, which is 120. So then you're kind of formed into allied angle formula over here because of 90, and you know that when the allied angle comes, and if it's with reference to the y-axis or 90 degrees, then the function translates into a co-function. So the co-function of cos is sine, and this angle gets retained, it's sine, and the algebraic sign over here will be the sine of the original angle. So if you take cos 120 will fall in second quadrant, and second quadrant cos is always negative, and hence this function is going to be negative, and this equals to minus half, right? Sine of 30 is minus half. So if you see here, this whole substitution we got as minus half over here. Okay, so what you can do is we can rewrite here on the left hand side. I'm going to take back this original color, sorry. Okay, you can rewrite. So I'm going to take this 2 out here, so this 2 and this 2 becomes 1 by 4, and within the brackets, this whole equation, this whole thing has been mapped to minus half, right? So I'm going to say minus half plus, we don't have to forget this cos of 140, this is still here. So this minus half plus cos of 40 and into cos of 20, which was already there from here, right? And then I'm going to write this formula as, I'm going to expand the bracket so that it's easy for me to compute. So if I take this, I can rewrite this cos 1 by 4 into cos of 20 minus half plus cos of 40. Okay. And then I'm going to open up the bracket so that I can simplify it. This equal to 1 by 4 into cos of 20 into minus half plus 1 by 4 into cos of 20 into cos of 40. So I've expanded the brackets, and always remember that we need to get the value as right hand side is equal to 1 by 16. So eventually all the cos functions should go, and the clue for all this kind of problems is whatever is the angle which cannot be substituted further, in this case cos 20, will eventually get cancelled out in some fashion, and then you will see that how we do that. Okay, so now if you take this over here, let's continue. So if you take this and this becomes minus 1 by 8 into cos of 20 plus 1 by 4 into cos of, I'm just going to rearrange cos of 40 into cos of 20, like just take the bigger terms first, just for it's easy optics, that's all, nothing more than that. And now let's again solve for this, right, this puppy here in the same format. Like I said in the beginning, right, you have to substitute it twice because you've got 3 cos functions. We'll substitute twice, and for doing that, what I need is I need to get 2 in the formula, because that's how the formula will fit in. So I'm going to divide and multiply by 2 over here and make it uniform, and I'm going to copy this as it is. Alright, so far we are good. I'm going to just again draw something on the right side so that we can draw this. So now we are going to solve for this piece. This piece looks like the one I told you, right? 2 cos, the same formula I'm going to apply, whereas this will become 40, will become A will become 40 and B will become 20. Okay, so this 2 into cos 40 into cos 20, if I apply the same formula like that I applied over here, right, cos A plus B and cos A minus B, what it will give me is this left hand side will become cos of 40 plus 20 will be 60, and plus cos of 40 minus 20 will be 20. Like I said, whenever you add or subtract, one angle will be a straightforward angle for which you will know the value, and the other angle will be odd angle. And over here, if you see, I told you that somehow the cos of 20 should get cancelled out because you need a final value as 1 by 16, and we'll see that's how this will be going. So now this becomes cos of 60 plus cos of 20, and cos of 60 we know that it's half, then becomes half of cos of 20. Now if you substitute this over here, the blue one I'm going to write is, okay, let me write this blue one first. So this becomes 1 by 8, and you can see that we are getting closer to this equation. This becomes 1 by 8 into, in the bracket you get half plus cos of 20, right? And then the blue part stays as it is, 1 by 8 cos of 20. Now let's see, let's open up this brackets over here and let's see what happens. Okay, so if I open up the bracket here, minus of 1 by 8 cos of 20 plus 1 by 8 into half is 1 by 16, which is what the answer is if you get, plus 1 by 8 into cos 20 is 1 by 8 into cos of 20. And if you see here, this particular piece gets cancelled out with this, and what remains is equal to 1 by 16, which is our value on the right hand side, and hence we have proved that the whole right hand side matches to 1 by 16. So this is what the final answer is. So it's that simple, nothing much. You have to substitute twice. Be careful, you already know the answer. Rearrange the terms so that you don't mess up, and it's very easy for calculation. And like I said, you can pick up any 2 angles, it does not really matter, and then you can slowly substitute that. And you should know, sometimes you'll be able to apply the allied angle or multiple angle to simplify this value, because it's more than in the first iteration it's more than 90 degrees, so you applied the concept of allied angle. In the second iteration it was less than 90 degrees, cos 60, so it becomes like a reference angle. You know the value for any cos functions, the standard functions 35, 30, 45, 60, you applied that and then you get the answer. That's how you kind of solve this problem on this one. So it's easy puppy, 4 marks, you can score it well, no problem. And this other problem, sine 20, I'll just pre-write it and just trying to explain you in the other videos real quick, because there are some negative signs here, you just need to be careful. I'll highlight those. Otherwise this is what it is. As always, don't forget to write the formula carries marks, and then you're good to go. Thank you, and I'll see you in another video.